So hello guys. So today we will learn subtopic of force and motion, which is pulley system. So the first one is pulley system. So what is pulley system? So a frictionless pulley serves to change the direction of a force. And when a force pulling a mass over a pulley. So from this situation we could see the first situation where a boy started to pull a bucket with a mass of 3 kg. So for the first question, find the tension of the stationary. Find the tension of the bucket if the bucket is in a stationary. So as we can see here, there is a rope which will cause a tension upward. Therefore, by applying F equal to ma, which is the first equation, and F is equal to T minus mg equal to ma, as we could see that the resultant force is the force is in equilibrium. So T minus mg equal to ma, and m is 3 times 10, which is the gravitational acceleration, and the a is equal to 0 because the object is in stationary and no acceleration applied there. So T is equal to 30 Newton. And next is when the bucket moving upwards with a velocity of 2 meter per second, which is we can apply it uh, as the acceleration is equal to 2. So using the same equation, T minus mg equal to ma, where 3 times 10 equal to 3 times 2. So we can find the T which is 36 Newton. So the applied force is 36 Newtons. So next is for the force in equilibrium. So force in equilibrium, as we can see that they are when the force are in equilibrium, so the net force, which is the resultant force, will be equal to 0. So the object from the equilibrium force will be either be at rest or in a motion of constant velocity. And for an inclined surface, there are two resultant of forces, and and we need to find the resultant of two forces and also the resolution of forces for an object on an inclined plane. So an addition of resultant forces, we can see that when the object is moved with is applied with a force with the same direction, so we could add up and sum up the forces applied on the object, so we can get the resultant force. And to find the resultant force, uh, for an object with a same direction of forces, we could add it, but for the object with a different direction of forces, we need to uh, apply with a different sign, which is the positive and negative, as we can assume the positive to the right and negative to the left. And after we sum up, the total will be for 4 Newton to the right, 3 Newton to the left, and we sum up, will we get the resultant force, which is the 1 Newton. And for forces with an angle, we could use two methods to determine the resultant force, the direction of the resultant force, which is the first one. We could use the triangle method. So as the first, we could draw the force horizontally to the right, and then with an angle to upwards. So from this we could see that it will form a shape of a triangle. So this will be the direction of the resultant force. Or next one, we could use the parallelogram rule, which is from the force applied to the upward with an angle and horizontally, we could apply a shape of a parallelogram with the same length. So we could see that there will be an intersection for the both forces of the parallelogram, and this intersection will go through to the middle of the origin. Therefore, we could determine the direction of the resultant force. And for your information, for the force, with the for a resultant force, we could get the value of the resultant force by using the Pythagoras theorem, which is the F1 square, the horizontal force squared, plus with the vertical force squared, and we square it. So this will be the resultant force. And for to find the angle, we could use the tan theta equal to F2 over F1, which is the vertical over horizontal. So the next subtopic is work. So a work is done when a force causes an object to move in the direction of the force. So a boy with a bicycle moves forward with applied force on the bicycle, and also a man with a barbell, lifting it upwards with a direction and displacement. So we can calculate the work done with formula W equal to Fs, which is F is force times with the displacement of the direction of forces, and the unit is joule. So a box supplied with 1 Newton move forward to a 1 meter place. So the work done is equal to 1 Newton times 1 meter, which is equal to 1 joule. And for the first example, a boy pushed a trolley with a force applied 120 Newton to a place of 15 meter. So the work done can be calculated with 120 times 15, which is equal to 1800. So the second example is a girl with a luggage pulling the luggage with an angle of 40 degree with a force of 30 Newton to forward to the right with a displacement of 15 meter. So to calculate this, we need to first find the horizontal force, which we can use the formula of Fs cos theta, which for to find a horizontal force we can use the F cos theta and time with displacement to find the work. So F cos theta, which is 30 cos 40 times with the 15 meter, and we could get the work done is 345 joule. So the next one is there is no work done when the force does not move. So as we can see that here a boy is lifting the book upward with the book weight which contribute the force to downward. So this will be for the book will not move because the force is in equilibrium, no resultant force here. And the next one is the boy pushing a wall where the wall did not move and no displacement here. So when there is no displacement, the S will be equal to 0. So the work done is equal to 0. And the second example, which is a boy lifting the book upward with a 10 Newton and move horizontally. As we could see here that the direction of motion is horizontally while the force applied is vertically. So the work done is equal to 0 because the direction of the force, there are no displacement with the direction of the forces, so S is equal to 0. And last one, which is the work done against the force of gravity. So a farmer pull up a bag uh, with an upward force, so the weight is equal to mg, and the work done against the force of gravity, as we can calculate here with the mg, which is the weight, times with the h, which is the height of the bag moving downwards. So we can calculate the work done by the gravity here. So let's go to the next hard topic, which is energy. So there are a lot of form of energy here, which is gravitational potential energy, kinetic energy, elastic potential energy, heat energy, electrical energy, nuclear energy, chemical energy, and also sound energy. So energy can be transferred. From here we could see that a bodybuilder lift up a barbell, which cause an transfer of energy from chemical energy to a potential energy. So chemical energy that's stored in a food in a weightlifter transfer the barbell, which possess energy due to its position, which cause the gravitational potential energy, where the barbell is influenced by the gravity. And the next one is the chemical energy to the kinetic energy, where a baseball pitcher throws throws the ball. So the work done is transferred by chemical energy to the baseball, which form a kinetic energy as the ball move towards the direction. So potential energy is defined as energy stored in object because of its position or its state. So the position of a object. And gravitational potential energy is where, for example, where a boy lift up a box toward a certain height, so the force lifting the box upward is applied, and there are the weight of the box will push the box to the downside, which cause the gravitational potential energy. As we know that the weight is in the weight, there are mass and also the gravitational acceleration, which cause the box to move downwards. Example of a pole vaulter of a mass 55 kg clears the bar at 6 meter height. So from this height of 6 meter, the pole vaulter is on the top of the bar. So we need to calculate the potential energy of the highest point, which is the 6 meter. So using the equation, potential energy, which is EP equal to mgh, so the mass times the gravitational acceleration times 6 meter height, which is equal to 3300 joule. So this is the energy or the work done. So next is kinetic energy. So kinetic energy is energy possessed by an object due to its motion. So this is how the kinetic energy was derived. So the most important thing to remember is the kinetic energy, which is Ek equal to 1 over 2 mv squared. So let's see the example. So a pitcher throw a ball of mass 145 gram with a speed of 20 meter per second. So what is the kinetic energy? So here we can calculate using the equation of kinetic energy equal to 1 over 2 mv squared. So half time 1 over 2, half times 0.145, which is the mass in kg, times 20 squared times 2020, so which is equal to 29 joule. So now let's go to the next subtopic, which is power. So power is the rate at which work is done. So we can calculate power by work done over time taken, will be equal to P power, or P is equal to energy transfer over time taken, and the unit for power is watt. And there are two conditions to determine the factors of powers. So the first one is when the work done is higher, so the power also will be higher. As we can see for the first example, there are two librarians. For the first librarian, which it hold up only one book, and the second librarian hold up about two books. So this show that the second librarian has the work done by the second librarian is higher, so the power required for the circular brake is higher. And next is the second factors, which is the time taken. So as we can see from this example, two cars with different type. So the first car takes about 5 seconds with a same velocity, which is 8 km per hour, to finish the race, while the second car took about 10 seconds to finish the race with the velocity of 8 km per hour. So car A, the first car is more powerful because it has less time taken to finish the race. So let's see the example. So a stuntman with a mass of 60 kg climb height onto a roof of a building of 56-meter height. If the power generated by the stuntman is 2.1 kilowatt, how long does he take to complete his task? For power, the formula is power equal to work done over time taken. So the work done is already given 2.1 kilowatt, which is 2100, equal to mgh, which is the gravitational energy, potential energy, mgh. So as this height refer to the potential energy over the time taken. So for this question, the question asks the time taken for the stuntman to complete the task. So by the formula, the unknown the unknown that we need to find is t, the time taken. So 60 kg times 10, the gravitational acceleration, times 56 meter height over t, equal to 2100 kilowatt, 2100 watt. So the answer is t equal to 16 seconds. So work done is power is equal to work done over time taken, and if we derive again, we could get the P power equal to F times V, which is force times velocity. As for example, a car moves to the right with a velocity of 30 meter per second and a friction of 700 Newton acting on the opposite side. How to solve this question? So the solution is, since the car moving at a constant velocity, so the F net, or the resultant force, is equal to 0. So the total resistance force, which is F, acting to the opposite side of the moving car, which is 700 Newton, and the power required for the car to move forward, which is F times V, which is 700 times 30. So the answer will be 21 kilowatt. So next one is efficiency. So we can calculate the efficiency of a device using the formula of the useful output energy over input energy times 100%. The higher the efficiency, the lower the energy input needed.